This is Math 2, 10.5 notes. That's Math 2, Unit 10, Lesson 5. The title is Solving Quadratic Equations, and I have three graphs here. We're going to draw three different parabolas. Now, it doesn't matter if your parabolas are opening up or down, but I want you drawing them somewhat like I did here. And then one more, we're going to draw it over like this. Okay, now we're going to talk about x-intercepts. So, x-intercepts are where you cross the x-axis. So here you can see I have two x-intercepts. Here you can see I have one x-intercept, and here I don't have any x-intercepts. So that's what we're going to be talking about today, finding x-intercepts. And how many are there? Are there one? Are there two? Are there none? Are there two? Are there one? Are there none? Those are the three possibilities we're going to end up with. Now, I'm hoping it makes sense for any parabola that you're never going to have a parabola with three solutions, because it's never going to do this and then wrap back down again. That's a whole different function. It's not a quadratic function. So the most you're going to have is 2, 1, and then 0. Most is 2, smallest amount is 0. Okay. Solve and state the number of x-intercepts. Okay, I'm going to come back up to the top really quick. What did I say earlier? This is 2 x-intercepts. This is 1 x-intercept. And this is 0, or no. I'll put no. No x-intercepts. All right, what's another way of saying this? This would be 2 real solutions. We're going to talk about imaginary solutions eventually. This would be 1 real solution, and this would be no real solution. Okay. Solve and state the number of x-intercepts. Number 1, y equals 2x squared minus 32. Okay, so you want to isolate the x squared just like we would isolate an x. So you're going to add the 32 to the other side. Actually, before I go any further, solve and state the number of x-intercepts. When you're looking for x-intercepts, you will always make y equal to 0. That's the way x-intercepts work. X-intercepts, y is 0. You can see that here. You go left, say 4, and you don't go up or down. You go right 2, and you don't go up or down. X-intercepts, the y value is 0. So plug in 0, 2x squared minus 32. All right, and then we solve. Move the 32 over. 32 equals 2x squared. Divide both sides by 2. X squared equals 16. And then remember, how do you undo a squared? You square root, because square roots and squares are inverse operations. They undo each other. Undo. X equals. Now, when you take the square root of both sides of an equation in order to solve, you will always do plus minus. X equals plus or minus the square root of 16 is 4. And the reason that is, they're asking you here, what number squared would give you 16? Well, 4 times 4 is 16, and negative 4 times negative 4 is also 16. So both numbers would work. That's why we put the plus or minus when you square root both sides of an equation to solve. Okay, number 2, y equals 5x squared plus 100. Okay, we're going to, coming back to number 1, I forgot to state the number. Solve, which we did, and state the number of x-intercepts. Okay, how many x-intercepts did I end up with? 2. So there's 2 questions here. X equals plus or minus 4, that's 2 x-intercepts. It looks like 1, but there's really 2, positive 4 and negative 4. Okay, next one, we're going to subtract the 100. And I jumped the gun again like I did in the last one. Before subtracting 100, what should I do if I'm finding the x-intercepts? We have the note right there. We should make the equation equal to 0. 5x squared plus 100. Okay, now we're going to subtract 100. negative 100 equals 5x squared. Why is it negative 100? Because 0 minus 100 is negative 100. And then I divide both sides by 5 to isolate the variable. X squared equals negative 100 divided by 5 is negative 20. And you square root both sides. Square root, square root. Now, can you take the square root of a negative number? No. It's not possible, not for a real solution, and that's what we're looking for. So no real solution is the answer to the solve piece. Solve the equation. The answer is no real solution. Why? Because you cannot take the square root of a negative number. It's not possible to multiply any two numbers that are exactly the same and get a negative answer. 5 times 5 is a positive 25. Negative 5 times negative 5 is still a positive 25. Two numbers that are exactly the same multiplied together would never equal a negative number. No real solution. What does that mean about my x-intercepts? There are none. No x-intercepts. Okay, number 3. 0 equals x minus 3 squared. Okay, these are already equal to 0, so we just have to go through and solve. We don't have to worry about doing that first step that I kept forgetting up there anyway. Okay, going straight to solving. Now, look at this one. I have a minus 3 that I do want to get rid of, but it's trapped inside the parentheses. Can you see the difference here between that minus 3 and that minus 32? That minus 32 is easy to move over. This one is not because it's trapped. So what do I have to do? I have to get rid of the squared first, and I get rid of a squared by square rooting, inverse operations. Square root of 0 is 0, plus or minus, always 0. They undo each other, x minus 3. Now plus or minus 0 is just 0. You don't have to worry about treating it separately. And then we solve by adding 3. X equals 3. All right, how many x-intercepts did I end up with on this one? Only one. One x-intercept. All right, so we've seen problems where there's 2 x-intercepts, no x-intercepts, 1 x-intercepts. Those are the 3 possibilities we're always going to end up with when we're solving for x-intercepts on a quadratic function. Number 4, the quantity of x minus 5 squared minus 24 equals 0. So this one already has the equal 0 in there. And I cannot minus 5 with the negative 24 because this is inside with the square, that is outside. Now I can get rid of the 24 first. That one I couldn't do the 3 because it was inside. But since the 24 is not inside the radical, or inside the, the quantity squared, you can get rid of it first. X minus 5 quantity squared equals 0 plus 24 is 24. And then we square root both sides. Why? Because I cannot add the 5 because it is trapped inside the parentheses, and what's keeping it trapped is the squared. And how do I undo a squared? With a square root and a square root. Okay, x minus 5 equals plus or minus the square root of 24. Okay, now I am going to simplify plus or minus root 24 because I can break it down into its prime factors. 8 and 3, 4 and 2, 2 and 2. I have 2, 2, 2 and 3. I'm going to write that right here. 1, 2, 3 2s and 1 3. And only one set comes out, so it's 2 root 6. X minus 5 equals plus or minus 2 root 6. I'm not done because I have to add the 5 to the other side. Now when you add the 5 to the other side, it is not a like term with the radical, so this is how you're going to write it. X equals positive 5 plus or minus 2 root 6. Now a few things. You could put plus or minus 2 root 6 first and then the plus 5 at the end. I like writing it this way because that's how our answers are going to look eventually anyway. I cannot add the 5 with the 2. I cannot say 5 plus 2 is 7, 5 minus 2 is 3. I cannot do it because the 2 is attached with the root 6. It's like saying this, 5 plus 2x, those are not like terms. 5 minus 2x, same thing. You cannot add or subtract that. You would leave it like that, leave it like that. 5 plus 2 root 6, 5 minus 2 root 6. This one here, you could condense it to 5 plus or minus 2x. Same thing. I cannot add them because they're not like terms. So that is it. You are done with that problem. Okay, number 5. -5 parentheses x plus 6 quantity squared plus 35 equals 0. All right, I want to isolate the quantity squared first. So what would I do? Could I distribute the -5? I cannot because of the quantity squared. What would I do first? I would subtract the 35 first. Always add or subtract when you are solving equations first. Okay, so subtract the 35 from 0, crosses out there. The -5 stays out front. X plus 6 quantity squared equals 0 minus 35 is -35. All right, now I already said I cannot distribute the -5, but I can divide it to the other side, and I have to because I want to get rid of it. I'm trying to isolate the quantity squared. X plus 6 quantity squared equals, what is that reduced to? +7. Okay, why am I trying to isolate the quantity squared? Because I want to square root it to undo the squared, and I can't square root it until everything around it is gone. The 35 has to be gone, the -5 has to be gone, and I do that by subtracting the 35 and then dividing the -5. Undo. X plus 6 equals, don't forget your plus or minus. A lot of kids forget that. And then I'm going to subtract 6 to the other side. I like to put my -6 in the front, plus or minus √7 in the back. They are not like terms. These are two answers. Now, one thing I did forget to do on this one was state the number of x-intercepts. So I'm going to do that now. There are 2 x-intercepts here. Why are there 2 x-intercepts? Because 5 plus 2 root 6 is one of them, and 5 minus 2 root 6 is the second one. So here, there are also 2 x-intercepts. You do not have to rewrite them, but I'm going to put a little thinking bubble here. It is -6 plus √7 and -6 minus √7. Can you see that there's 2 of them there? You don't have to separate them, but there are 2 solutions. Okay, number 6 and 7 we are going to do in class. That is it for this lesson.